All right, remember, you guys are doing, this is not 6.3, but 2.3. These are the notes for 2.3. These are not on your next checkpoint quiz, which is tomorrow, since this is our Flex Day video. This notation that we're looking at is not my favorite notation. It says F following G of 5. Okay, now, I would prefer writing it, and I will write it, F parenthesis G of 5. Now, here's why I'm going to write it. In fact, maybe I should change that to a different color inside there, because the first thing we need to do is find out what G of 5 is. In other words, you're going to find the part on the inside first. So if I come here and I find G of 5, obviously that's 5 squared minus 1. I didn't have to use parentheses because 5 is not a negative number. For those of you wondering, we did use parentheses yesterday and made a big point out of that, and have for several days now. So 25 minus 1 is 24. So we are going to rewrite our question, F of 24. In other words, what we did was we took this value and we put it in there. So F of G of 5 is the same thing as F of 24. So we truthfully need to just do 24 minus 1. And 24 minus 1 is 23. So the final answer to our question is 23. This is not multiplication. Okay, you cannot get it confused with multiplication. And I know some people won't take good notes. They think this is the same thing as F of 5 times G of 5. Okay, not at all true. You're going to get it wrong if you do F of 5 times G of 5. Okay, so don't do that. Okay, so continuing the same type of strategy, just rewriting this, G of H of 0. So find the part H of 0 first. 0 squared plus 1. Of course, that's 1. So my question is now G of 1. Well, G of 1 would be the same thing as negative 3 times 1, right? Because I'm just taking that 1 and I'm plugging it in here. And negative 3 times 1 is negative 3. So take it a step at a time, and you probably won't have a whole lot of issues. Try to erase. Oops. Gotta lock it to erase. Okay, so F of G of negative 5. So first we find that, G of negative 5, that's negative 5 minus 5, which is negative 10. And then we find F of negative 10, which is negative 10 squared. Now remember, we talked about parentheses and how they make a big difference when you're talking about negative numbers. That's important. So my answer is 100. This one's a little bit different. Because in this particular one, they're only using one function. but they're using it twice. So first I need to find out what f of 9 is. So that's 5 times 9 minus 3. 5 times 9 minus 3, so that's 45, take away 3. So now I know that this part right here is 42. Now they're asking me to find out what you get when you plug 42 into f. In case you're wondering where some of these types of things happen, Excel spreadsheets do these kind of things all the time. They take values from one box and they use them in a different formula for a different box. So if you've ever used Excel or Google Sheets, Excel spreadsheets or Google Sheets for different things in different classes, you use this idea of embedding, of taking a value from one place and using it in another. So if you change the original box, you change more than one box, right? So we want 5 times 42 minus 3. 5 times 42, that's 210. Take away 3, 207. So, continuing this idea of practicing, we want f, f of, and this is a completely separate problem from that, h of negative 6. And so h of negative 6, that's, let's see here, negative 6 minus 5 over 3. That's negative 11 over 3. That's ugly. So now I want f of negative 11 thirds. F of negative 11 thirds. So that's negative 2 times negative 11 thirds minus 1. I'm guessing you grab your calculator. And that's 22 over 3 minus 1, which is 3 over 3. I'm guessing your calculator is going to give you 19 over 3. Or 18, oh, not 18, what am I thinking? 6.3 repeating. So I don't care whether you give it to me as a fraction or as a decimal, whichever you prefer. Okay, now, question 6 on down starts getting into something different. No longer are we going to be using numbers, but we're going to be using just letters. Okay, now, it's not as bad as you think it is. So, remember, the first question is asking me, what is f of g of x? Now, g of x, we know that's x plus 2. So this question, oops, let's use my colors the same way I've been doing. This question is really, the first question here is asking me to replace every x with an x plus 2. So that means 4 times something minus 3, and we're replacing it with x plus 2. And of course we'll distribute it and get 4x plus 8 minus 3, which gives me 4x plus 5. Now more than likely we are not going to get the same answer going the other direction, so don't just write down 4x plus 5. It is possible, but I highly doubt it in this case. When we do the other part, g of f of x, which is equal to g of 4x minus 3. And I'll explain this more when we get to the next example, just because, you know, we're continuing to practice. I've got a better way to think of this question. So the g function says whatever you plug in, you add 2. That's what the g function says right there. Whatever you plug in, you add 2. We're plugging in 4x minus 3. Now, in the future, I'm going to ask you, and I should have asked you that on the previous one, on the previous question, are these parentheses useful or useless? Well, in the first example, they were useful. But these parentheses right here, over on the second example, or second part of question 6, are useless. They're not useful. So I literally can ignore those parentheses and get my final answer of 4x. Let's see, negative 3 plus 2 is negative 1. Notice that I did not get the same thing both times. Now, I kind of showed you the long way to look at it in the previous question. Let me kind of show you a shorthand version, somewhat. Think about the one on the outside. The one on the outside is controlling what's really going on. So the one on the outside says 5 times whatever you put in minus 1. Now if I come down here and do the same thing on the other one, because it's got something on the g is on the outside, it says whatever you plug in, you add 9. Okay, so notice that I first looked at the outside function to decide what to put in. Okay, now, what do I put in? According to this, I put g of x in, which is x plus 9. According to this, I put f of x in, which is 5x minus 1. Once again, are the parentheses useful or useless? Well, they're definitely useful in the first one, 5x plus 45 minus 1. They're definitely useless in the second example. 5x, and then minus 1 and plus 9, it makes plus 8. So first one I got 5x plus 44. And the second one I got 5x plus 8. Okay, so let's kind of walk through that rationale again. The one on the outside controls what's going on. The one on the outside says 5 times whatever I plug in minus 7. The one on the outside for the second one says whatever you plug in, add 9. Okay? What are we plugging in? We're plugging in g of x, which is x plus 9. What are we plugging in here? 5x minus 7. Useful, parentheses. Useless, parentheses. Minus 7 plus 9 is plus 2. So we've got 5x plus 2 for that one. And 5x. 45 take away 7 is 38. All right, I'm going to skip number 9. Seems like it's the same one. If you want to try it just to make sure you understand it, go for it. Actually, whoa. Are you kidding me? Is that it? All right, we'll do it just for fun because we need the practice. The part on the outside tells me what to do. 5 times whatever I plug in minus 4. The part on the outside tells me what to do. Something plus 9. And And then I plug in what's on the inside. So g of x, which is x plus 9, goes in the inside. F of x, which is 5x minus 4, on the inside. Useful parentheses in the first one. Use less parentheses in the second one. 5x, let's see, negative 4 plus 9 plus 5. So we ended up with 5x plus 41 and 5x plus 5. I hope that the use of colors has kind of helped you understand, what part you do first, what part you do second, so forth. I know that I kind of went overboard on the notation on number 6 compared to 7, 8, 9. You don't need to do as much as I kind of wrote out on number 6. I just wanted you to kind of see or follow the logic of what we were doing. Okay? I literally can kind of follow the logic of what I was doing on 7 and 8 and 9. So, we can go ahead and get started on the section 4, but we won't get as far. We won't get too far. Hold on while I pause this. There are two basic functions that I need to describe to you on lesson 2.4. Two basic functions are the absolute value, which we've already kind of talked about. The lines come from the origin and they have a slope of 1 and negative 1. And then the other one, y equals x squared. And that parabolic shape looks like this. You've seen that before in Algebra 1. Those are the two shapes we're going to be dealing with in this particular section. Now, the multiplier in front of either one of these shapes causes it to either open up or down. If it's a negative number, like it is in this case, then it opens down. So this is not an option, and this is not an option. If that multiplier is close to 0, in other words, it's a fraction, then what it causes the graph to do is flatten out. Now, I'm going to zoom in on the graph because you can see what the lines are. If you go down 1 and 3 to the right, you find one of the points. Likewise, if you go down 1 and back 3, you find points. That's not going to be true over here. On this graph, you have to go down 3 and over 1. Down 3 and back 1. So this is actually y equals negative 3 times the absolute value of x. So the slopes of the lines can help you find that coefficient. Describe the transformation from the parent function. Okay. It is reflected across the x-axis. That's true. That's true. And it got vertically compressed. That idea of flattened out, vertically compressed. And it didn't get taller and skinnier. It got shorter and fatter. It got flattened. Graph the equation. Okay. Well, can't be either of those because those both go up. This is clearly going down, right? The slopes of the lines are based on 5/4. So, let's look at the picture and see what we've got. Down 1, 2, 3, 4, 5. 1, 2, 3, 4. Hey, there it is. Right? Down 5/4. So this is the right one. -5/4 times the absolute value of x. So what was the other one? I bet it was flipped around. Yep, down 4/5. Yep, down 4/5. So this one was y equals -4/5 times the absolute value of x. What were the other ones, just for fun? Looks like that right there. So that's up 4/5. So this one was y equals 4/5 absolute value of x. And it's got to be positive because it's going up. So that's the idea. Which statement below? Ooh, we wanted this one. The parent function is reflected in the x-axis. Okay, so it's got to be one of those two down here. And this time it is stretched, okay, because it's steeper. Now, it's not steep by a lot, you know. Going down 5/4 is pretty close to down 1/1, but it is steeper. You know, it's not stretched a lot, but it is stretched some. It's not. It's taller and not flattened out like the other one. Without graphing, identify the vertex axis of symmetry. Okay, so see if I can help understand this x minus h plus k. This is a generic version of the absolute value function that you're dealing with. And the vertex is always located at the point hk. hk. H goes with the x-coordinate, k goes with the y-coordinate. So, in this particular case, now keep in mind that the minus is part of the equation. So, h and k. The reason I say that is because I always say that it looks backwards for the x, but it looks exactly like what you think for the y. Backwards for the x, but exactly what you think of for the y. Because we have moved this graph right 6 and down 2. The movement inside the absolute value bars kind of goes against your common sense, unless you think that in order to make up for the subtraction of 6 units, you had to get bigger x values, which means that your x's are larger and farther to the right. Now, the axis of symmetry is the line which, vertical line, which cuts graph in half. We know that vertical lines are always of the form x equals some number of the universe. Now, if the vertex, now maybe I should back up. Maybe the vertex, I should say, is the point where the V comes together. So this point right down here would be called the vertex. It's the point where the two lines change directions, basically. The axis of symmetry is a line which goes right down the middle of that. So if you know the vertex, then you know that the axis of symmetry would be x equals, they already have the x equals part, so I don't have to write it. Well, all I do is borrow the number for the vertex, so x equals 6. If you know the x-coordinate of the vertex, you know what to use for the axis of symmetry. Okay? Now, the number that's in front of the absolute value bars is a positive 1, which means that there's no stretching, there's no shrinking. The slopes of the lines are 1 and -1, just like they should be. So, to say stretched, these aren't even reasonable choices. So A, C, and F are not reasonable choices for this answer. We do want to say that the function is translated 6 units to the right, okay, 6 right and 2 down, and that would be choice B. 6 right and 2 down. All right, let's see if we can write an absolute value and make this our last one for the flex day notes. Y equals. All right, now it gives us a clue right here. It's an absolute value equation. So I'm gonna blow it up a little bit here just to kind of. We know it's an absolute value, and we know that it's been moved right 3. So if I want to say right 3, that would be x minus 3. That's right 3. And we went up 2. So in order to say up 2, we'd have to put a plus on the outside. Now the slopes of the lines, if I look at those slopes a little bit more carefully, I can see that they go up 1 over 1, 2, 3, 4, 5. Up 1 over 5. So, since it's positive, that's up 1 over 5. And it has to be positive because it's opening up, opens up. So that's why this is a positive. Well, there we go. We got everything we need. We wrote our equation based on the picture. We'll talk more about that stuff in class. Have a great day.